right, we are dealing with rational instructions. We talked about writing them in lowest terms, finding the domain, which we know we have a fraction, the denominator can't be 0, and we talked about multiplying and dividing and reducing those things. So let's talk about addition and subtraction. If I gave you 2/3 plus 4/7, and I told you to add that without grabbing a calculator. If you want to add or subtract fractions, what do you have to have? Okay, what would that be? Alright, so if I want to turn this one into 21, we would have to multiply by 7 on top and bottom. What would you have to do to this one? When you add those, you add the tops, so we get 26. The denominator does not change. What should you check at that point? Yeah, make sure it's in lowest terms, and there's no greatest common factor that we can reduce by. We can't here, so that's our final answer. So we're going to use this same idea when we add and subtract rational functions. A couple of you have already done this assignment on the Math Excel. You finished it, which is great, so that tells me you remember it, but we may not all remember, so I'm going to go ahead and work through it just in case. Why do I have up here x cannot be negative 5 halves?
Because that's what we did when the index and all that is 0.
No, that's the domain. We did domain yesterday. We talked about in the fraction the bottom can't be 0. So my domain is x cannot equal negative 5 halves. This has absolutely 0 impact on how we solve the problem. But I really just put it here because ACT is really good at that. When they give you a question, they add all these other things on the end, and people end up focusing on that instead of the problem. Okay, that's just the domain. Doesn't matter to us. We're just solving this problem. In order to add fractions, we have to have a common denominator. Do I need to do anything special? No, we have it. So we're just adding the tops together. Add like terms. You can list them in any order. So I'm just going to go decreasing order. So 2x squared plus x. Negative 4 plus 3 is negative 1. Questions there?
We don't have to give up the thing.
Okay. So that's a good question. If we looked at the top of this, could we factor it? So if we did our slip and slide, this factors into x plus 2, x minus 1, divide by 2. So these are equivalent. Does anything cancel out if I do that? No. So I would accept either answer. If there's anything that cancels out, I do want you to reduce that. For the most part though, I'm really focusing on the adding and subtracting here, so most of these are not going to reduce at all when we get to that point. All right. Other questions? Alright, this one. Make sure you guys are with me. You'll have time to work on the homework, I promise. Do we need to do something here? We need the same denominator. I have a 5p and a 4p.
20p.
Okay, we could turn them both into a 20p. So the first one, So that gives me 32 over 20p. This one we multiply by 5. We get 15 over 20p. So add like terms, we get 47 over 20p. Kind of as a side note, on this problem, I always have people that want to multiply by 4p and 5p. Would we be wrong? Let's see, if we did that,
It wouldn't really change anything because you just have to take out another p.
right, we would get 32p over 20p squared, 15p over 20p squared, so 47p over 20p squared, and then what happens? You can cancel out a p and you get back to that point. So if you don't get the least common denominator, you will have to reduce it later on, but that's okay, as long as you get the same denominator and then double check at the end that you can't reduce it any further. Let's look at this one. Do we have the same denominator?
You can multiply one of them by negative.
Okay. X minus 3 and 3 minus x are just opposites. So the easiest fix would just be to multiply one of these things by -1. Right, this would be a -3 plus x, which is the same thing as x minus 3. Can I add 2x and minus 5? No. So we just write 2x minus 5 over x minus 3 or -3 plus x. Let's try. Do a more interesting problem. You're sharing germs. You shouldn't drink after you
That is cool.
Sharing a delicious drink too.
So if I were trying to get a common denominator, I could just multiply the first one by x squared minus 1 and the second one by x squared plus 3x plus 2. But that's going to get pretty ugly, isn't it? We learned yesterday when we were multiplying and dividing these things, what was a good first option? Factor. I don't really want to do anything to the tops, which I can't factor those anyway on this problem, but you really want to start just with the denominators. So let's factor those denominators. So multiply 2 and add the 3. X squared minus 1 would factor in 2. Now we have to make our common denominator. So the first thing I see in the denominator is x plus 2. Does the second one have it? Nope, so it needs it. Alright, the next thing I have in the first one is x plus 1. Does the second one need it? No, it already has it. Alright, so we've taken care of the first fraction. The second fraction, we have an x minus 1. We need it in the first. . So on the top, I do want to go ahead and multiply this out, so we get x squared minus x. On the bottom, just like when we multiplied, I just said save your time, you don't have to multiply it all out, leave it in factored form. Alright, for the 2x minus 3, we have to FOIL here. 2x squared plus 4x minus 3x minus 6. Are my denominators the same? Yeah, it doesn't matter what order the parentheses are as long as they both have the same 3. So now we just add like terms. So x squared plus 2x squared negative x plus 4x minus 3x. That goes away. And then we have a minus 6.
Very simplified it.
Yeah. We could take out a 3 on top. Can you factor x squared minus 2 anymore? No. So I would accept either of these answers. You know, if we were going to factor out a 3 and something canceled, I'd want you to do that. Nothing canceled, so I'll take either one. Do you guys remember doing this before?
Yes.
Okay.
This gives almost elementary x.
That's good, because last year I feel like when I did this, people were ready to throw things at me. So, you guys aren't too overwhelmed? It's not a big deal yet? Doing okay? Yeah. Okay. Do you guys think you could try one like it? Okay, here's your problem. And then if we do okay, we'll move on. Wasn't it?
Yes.
That was kind of mean of me. I gave you guys a
How
hard
dare you.
time. I know, that was rude. I apologize. Alright,
How
so
would you not accept it?
first step. We need to factor these denominators. What can you do with that?
GCL.
X.
Alright, so if I take out an x, what am I left with?
X plus 1.
X plus 1.
Alright, what multiplies to 1 and adds to 2?
X plus 1 squared.
X plus 1 squared, or we could write it twice. Okay, did we get to here? So now we need to make the common denominator. So the first one has just a plain x by itself. Does the second one?
No.
So we need it. Alright, next we have an x plus 1. Does the other one have an x plus 1?
Yes.
Yes, so we're good. Alright, first fraction's covered. Second fraction, I still have a second x plus 1. Does the first one have that?
No.
So it needs another x plus 1. Whatever you do on the top, you do on the bottom as well. So if I distribute, we get 3x plus 3 over x times x plus 1 times x plus 1. Here, if I distribute my x, that's x squared plus 4x over x times x plus 1 times x plus 1. All right. So the other problems I've done, we've been adding. What changes with subtraction?
The second problem is all negative, all the signs get switched.
We just distribute that negative through the entire second fraction.
You don't do it on the bottom?
No, it's top or bottom. All right, so the bottom doesn't change. You could write it as what we had, or x plus 1 squared if you prefer. Then on the top, we have a negative x squared. 3x minus 4x is negative x plus 3.
Oh, I forgot.
You could list those in a different order. That doesn't matter. How did we do?
W.
If I didn't do it the way I could, I would have gotten it right.
Like,
If I didn't do it wrong, I would
No,
have gotten it right.
like the order. I didn't distribute my x and my x plus 1, so I went with like 3 minus
Too much.
x.
So it just wasn't simplified.
Yeah, because I'm silly.
Okay. Do we need another one like this?
No, we get it.
Strength.
One last type of problem.
Green ball or
And this
green?
you may not have seen before.
Oh,
Did you have any of these last year?
yes.
Oh,
I forgot.
this is easy.
Oh, no. So you take the
Yeah, you do the
1
thing
over
to the
x
thing.
and you flip this, you multiply. Yeah.
Do the thing, do the thing, do the thing. All right. You
I
want
know
to
what
teach
he's
it
talking
for-
about. I got him.
Okay, well we have options. Yesterday we divided fractions. How do you divide fractions? Multiply by reciprocal. But the problem is, down here, we would have to put those together first. If we want to add and subtract fractions, what do we have to have?
Common denominator.
Common denominator. So if we want to do that, it's kind of a lot of work. We have to get a common denominator on the top, common denominator on the bottom, then multiply by the reciprocal. We could do that. We've gotten common denominators, we've multiplied by reciprocal. So it would work. What makes this problem ugly?
Fractions.
Fractions and fractions. Okay, look at these fractions. What do they have in common? The denominator is x. Okay, we know it's legal if you multiply by the same thing on the top and the bottom of the fraction, right? So what if I take the top and the bottom both times x? It's legal, haven't changed our problem, same thing on top and bottom. Let's distribute them. So 1 times x, what would be 1 divided by x times x?
1.
So it would be x divided by x, which is 1.
Yes, sir.
Right on the bottom, if I distribute 1 times x,
Are they all gonna be that easy?
I wish.
pretty much.
I'll work it up.
Let's do one slightly harder one, and then I'm done. Slightly harder.
Slightly harder. And
The
it's like
hardest
the
that I
one
might give you.
made us do before. This girl. That's her name now.
Right.
Oh, so we have to like multiply the top one by 2x. Okay.
Okay.
I see.
Should.
So if we want to save ourselves all the headache of the common denominator and the multiplying by the reciprocal, which this one isn't quite as bad, so we could. Let me just ask you, we know we would have to multiply by the same thing on the top and bottom, right? What would I have to multiply by to get rid of this denominator? Okay. If I multiply by the 4, would it cancel this 2?
Sure.
1/2 times 4, does that give us a nice answer?
Yeah.
Okay, so that one will be taken care of, but we also need an x. Alright, let's see what happens. 1/2 times 4x. So 1/2 times 4 would be 2x. 4x times 3 over x. So what happens to the x's? They cancel. And then 3 times 4 is 12. On the bottom, the 4's cancel. So we really just have to distribute the x.
X squared is just 2x.
So that's a little shortcut to clean up when you have fractions and fractions. That's our final answer. Okay, so we have quite a bit of time left. Few things that I want to mention. Tomorrow, we are going to be reviewing the sections that we have covered so far. So section 2, that was just like adding, subtracting with polynomials, exponent rules, that stuff. Section 3, that was all of our factoring. And then section 4 is these rational expressions, so that math Excel thing. So So we are reviewing tomorrow. And then on Thursday, we are going to have a quiz. So I told you at the beginning, I don't believe in pop quizzes. I don't believe in surprises. I'm going to tell you, we have a quiz Thursday. Tomorrow we are reviewing the stuff that would be on the quiz. Okay? And I'll probably give you some practice problems tomorrow night for homework, like practice things I would ask on the quiz, just to kind of give you, make sure you feel prepared. So you have the rest of the hour right now to work on that math Excel assignment from yesterday.